This screencast is going to focus on word problems using the Pythagorean theorem. So you've now spent some time finding sides of triangles that you can easily visualize. We're now going to apply the Pythagorean theorem to some more relevant, applicable problems that you could even see in real life. So here we go. So here's example 1. From behind a tree, the sun casts a shadow 20 feet in length. If the diagonal distance from the end of the shadow to the top of the tree is 25 feet, how tall is the tree? And we should really add a question mark here. So again, what you want to do is make sure you draw a picture and label it, and we'll go from there. Here we have a diagram. We've got the sun behind the tree, and the tree casting a shadow, which would be here. So there's the shadow. And the distance from the base of the tree to the end of the shadow is 20 feet. And then we're looking at this diagonal distance, the diagonal distance from the end of the shadow to the top of the tree. So diagonal distance. And that is going to be 25 feet. And we're now looking for the height of the tree, and let's call it x. All right? So it's understood here that this really forms a right triangle where we know one of the legs, let's call it y. We'll label that angle y, and then that's y. And this would then be capital letter X, and then this would be capital letter Z, which will allow that to be Z. So we got Y and we got Z. So one of the legs, Y, is 20, and the hypotenuse Z is 25. So we could rewrite this Pythagorean theorem as x squared plus y squared equals z squared. I'll box a little area in over here. Allows me to move up a little bit. So I will. So we've just labeled the Pythagorean theorem as x squared plus y squared equals z squared because our legs are x and y and our hypotenuse is z. Filling in now, we are looking for x, so we'll write x squared plus y squared would be 20 squared is equal to z squared, which is 25 squared. So now it's a question of algebra, and again I'll move this up. Let's go forward and solve here, trying to get x by itself. So we have x squared plus, if we do 20 times 20, that would be 400 is equal to 25 times 25, which would give us approximately 625. So again, to get x squared by itself, we'd subtract 400 from both sides, subtract 400, and it would give us x squared is equal to 225. To solve for x here, we're going to want to take and move this up a little bit, the square root of both sides. So we take the square root of both sides, we get x is equal to 15. So the height of the tree would be approximately 15 feet. Let's take a look at example 2. In example 2, we have Bob. And Bob's out for a jog, and he's jogged 3 miles east, and then he's jogged 6 miles north. And we're trying to figure out how far he is from his starting point. As in example 1, we want to set up a diagram. So let's do x marks the spot here. So that's the starting point. And Bobby goes east 3 miles, and then he goes north, let's say 6 miles, creating a right angle here. So what do you know? Well, we know now we have this hypotenuse, and that's the distance that we're looking for. Let's call it y. lowercase y, which again means the angle opposite would be capital Y. And if we have this as x here, the side opposite would be lowercase x, and then let's call this z. So that's capital Z, and the side opposite would be lowercase z. So as I said before earlier, that we're going to be seeing triangles labeled differently all the time, so you just need to manipulate and go from there and be and improvise. All right, so we should be able to find y. We can write out the Pythagorean for this situation with the following letters. It would be x squared plus z squared equals y squared. And then we'll fill in. The x is going to be 6 squared plus z squared, which is going to be 3 squared, is equal to y squared. And if I move this up a little bit, get it out of the way. Yeah, we'll go here. We're going to get 36 plus 9 equals y squared, and then y is already by itself, so 36 plus 9 is 45 equals y squared, and then we will take and square both sides, and we'll get y is equal to the square root of 45, and you can leave it as that, or we could break this down a little bit more and you can do it on your calculator, and basically we would get y is equal to 6.71. So the distance from the starting point to where Bob is currently located is approximately 6.71 miles. Time once again for another edition of Try These. So if you're able to follow along with example 1 and example 2 of these word problems using the Pythagorean theorem, we're hoping that the next couple of examples you'll be able to do on your own with relative ease. And certainly if you're having any trouble, you can go back and watch, observe, listen to the first 2 examples. So here we go. So yeah, here's problem 1. In a computer catalog, a computer monitor is listed at 19 inches. This is the diagonal distance across the screen. If the screen measures 10 inches in height, what is the width of the screen to the nearest inch? Good luck. Here we have problem 2. A builder needs to add diagonal braces to a wall. The wall is 16 feet by 12 feet high. What is the length of each brace? So again, take the time to draw a diagram and apply the Pythagorean theorem to this problem. Again, good luck.